Hi, this is an Algebra 1 video, and the topic is multiplying polynomials. The first page we'll be looking at squaring a binomial using the FOIL pattern. Second page we'll review FOIL again. The third, we have a special pattern that's extremely important to know. It's called the difference of squares. And then the last page, we'll go beyond FOIL to multiplication of a binomial and a trinomial. But we'll see that the pattern from FOIL is just carried over and extended. So let's get started. Squaring a binomial using FOIL. Now, squaring, we could quickly review, is an exponent, and it's degree 2. And what it means is if we square 6, for example, or take 6 to the second power, that means 6 times itself. And our product is 36. Right, so we have a multiplication. Now, a common mistake here is to square n and square 3 and get something like n squared minus 9, or maybe you would think that this would become a plus 9, but it wouldn't matter. Either way, this is wrong. So what we should do until we get this pattern memorized is expand n minus 3 times itself. And now we want to use F.O.I.L, which stands for multiplication of the first terms. N times n is n squared. O is multiplication of the outer terms. N times negative 3 is negative 3n. I is multiplication of the inner terms. That's negative 3 times n, which is another negative 3n. L is multiplying the last terms. So negative 3 times negative 3 is a positive 9. And now we look at what we have. 1, 2, 3, 4 terms. These are like terms. Let's combine them, which will simplify our product into a trinomial. And this is the correct answer for squaring of n minus 3. Here we have a binomial multiplied by another binomial. Binomial, the prefix bi is saying that we have two terms. Each of these grouping symbols contains a binomial. And remember, f is for the first terms, x times x, x squared. No, sorry, not fi, it's fo, there we go. Although it's commutative, it wouldn't really matter. Negative 7 times x, negative 7x, 3 times x, positive 3x, 3 times negative 7, negative 21. And again, we have like terms, so we will simplify by combining. Negative 7x plus positive 3x is a negative 4x minus 21. And this product has 3 terms. We would call that a trinomial. Now, this binomial is degree 1 because that's our largest exponent of any term, and this trinomial is degree 2. Let's move on here to an important pattern, type of multiplication of binomials that we call difference of squares. Now let's work first by multiplying these we could call them conjugates because they have the exact same term, but in this binomial we're adding them, in this one we're subtracting them. And when we get that pattern for multiplication, the result is something called the difference of squares. Let's look at it. X times x, that's f, the first terms. X times negative 5, negative 5x, those are the outer terms. 5 times x, those are the inner terms. And 5 times negative 5 is negative 25. And now look at these like terms. They are opposites. Negative 5x, positive 5x. When we add those, we get 0. And so we're left with a perfect square number here, x squared, and another perfect square, 25. And we have a subtraction sign, which leads us to the name, difference of squares. So that's what we have as a result. This is called the difference of squares. It's a degree 2 binomial. Now, if you notice that you are beginning with the difference of squares, and maybe you need to factor them because you're trying to solve a polynomial equation, remember that we get conjugates. The square root of n squared and the square root of 16 being added, and then those same square roots being subtracted. So this process is called factoring, sort of the reverse of multiplying. And you don't need a variable to apply this pattern. Let's look at this. 81, which is a square number, 49 is a square number. This would also be factorable. What's the square root of 81? That's 9. And the square root of 49 is 7. So first we take the sum of those square roots, and then we take the difference, and if we add 9 and 7 and get 16, 9 minus 7 is 2. This answer, 16 times 2 is 32, is the correct answer for 81 minus 49. Okay, our last page. If we need to multiply some polynomials that are not both binomials, we have a binomial and a trinomial, a degree 1 and degree 2. It doesn't really matter what the degrees are, you can multiply any kind of polynomials together. But let's look at the pattern. X times x squared is x cubed. And notice if you've read up here that I'll be keeping track of partial products that are like terms. And I'm going to do that vertically. X times negative 5x is a negative 5x squared. X times 10 is a positive, so plus 10x. This is my degree 3 column, degree 2 column, degree 1 column. Now that I have distributed this first term to these three, I need to next distribute this constant. And now when I multiply 3 times x squared, that gives me 3x squared. I'm going to put that in the column with my other degree 2 term. When I multiply 3 times negative 5x, I get a negative 15x. That's also a like term with 10x. So this is my degree 1 column. 3 times positive 10 is 30. That gets its own column, the constants. And now this is an addition problem, where we combine like terms vertically. We get x cubed minus 2x squared minus 5x plus 30. So all of these partial products we combined to make our final product. This we would call a polynomial, which is a general term for any polynomial with more than 3 terms. And this is a degree 3 polynomial. Alright, keep practicing.